This is the solution for South Australian Matriculation Mathematical Studies, Common Test 3, 2011. Question 1. This is a question on probability distribution when a probability function and its respective value of m are given. Part A requires us to complete the probability table. To complete this table, we are to substitute the respective m, in this case are 0, 1, 2, and 3, into the function given above. When m is equals to 0, for example, we have k 3 over 4 to the power of 0, 1 over 4 to the power of 3. Calculating that, we get k over 64. So this is what we're going to do for the rest of the values of m. Putting in the value of k over 64 first for m equals to 0. For m equals to 1, we have 3k over 64. For m equals to 2, we have 9k over 64. For m equals to 3, we have 27k over 64. Part B requires us to determine the probability for m between 1 inclusive to 3 not inclusive. Note the inequality here. It is important to note this when you're calculating probabilities. Here m equals to 1 is included, while m equals to 3 is not included. Values in between 1 and 3 will be included. Henceforth, what we need to include here are the probabilities for m equals to 1 and m equals to 2. Adding the two probabilities, we get 12k over 64. You may leave your answer in fraction as it provides better estimates of the probabilities compared to decimal. Next, part C, we are to find the value of k. Noted the two important characteristics of probability, namely that the probability lies between the value of 0 and 1 inclusive. The second characteristic of probability is that the summation of all probabilities is equals to 1. So, using the later characteristics, which is the summation of the probability equals to 1, we have k over 64 plus 3k over 64 plus 9k over 64 plus 27k over 64 equals to 1. Solving for the value of k, I have k 8 over 5, or I can leave it to decimals as 1.6. The final part requires us to determine the mean. To identify the mean, we could use the formula, which is the summation of the probability multiplied by the respective value of m. Calculating this, we get the value of 2.55, and this is the mean of the distribution. You could also use the option available using GC to obtain the value. This option is better should you need to determine the standard deviation as well. Question 2. This question requires us to test whether there is any difference in the distance travelled by a car per litre of petrol with and without additive added. Understanding the question further, there should be no difference in the distance travelled, the mean would thus be 0. They tested this on 50 cars, of which mean and standard deviation obtained were negative 0.08 km and a standard deviation of 0.3 km respectively. Part A requires us to do a two-tailed z-test at a 5% level of significance on the information given above. As we are testing whether distance travelled is different or not different, the null hypothesis would thus be there is no difference in the distance travelled by a car per litre of petrol with and without additive added. It is written as h naught mu equals to 0. The alternative hypothesis will be written as HA mu naught equals to 0. Next part requires us to state the null distribution of the test statistics. Null distribution is another term for standard normal distribution. As such, it is written as z approximated to n 0, 1 square. Next, we are to determine whether or not the null hypothesis should be rejected. We could use our GC to easily calculate the z-value and the p-value. Z-value here is calculated to be negative 1.89, while the p-value is 0.0593. If we choose to test using the z-value, the calculated value does not lie within the rejected region, as the rejected region lies less than negative 1.96 or more than 1.96. The value of negative 1.89 does not lie within the shaded region. Alternatively, if we choose to test using the p-value, the calculated value is larger than 5%. Therefore, we can come to the conclusion that H0 is not rejected. State your conclusion from part A4. The conclusion of this test is that there is insufficient evidence to support claim that mean is different. Part B requires us to determine the 95% confidence interval for the mean value with interpretation. Using GC, we obtain the value of mean lies between negative 0.163 to 0.003.15. Therefore, we are 95% confident that the difference in distance travelled with and without additive added lies between negative 0.163 to 0.00315. Finally, the question asks us whether it can be concluded that the additive works effectively when the difference in the distance travelled with and without additive is above 0.2 at 95% confidence level. This is assessing claims using confidence interval. As such, we will compare the value of the claim with the confidence interval obtained in part B1, as the confidence interval calculated lies entirely below .2 kilometer. It cannot be included. Take note here, it will only be concluded in such a way if the confidence interval lies entirely above 0.2 kilometer, as with the claim. Question 3. This question is a probability question where Xavier is to prove that he has the ability to differentiate between a real and fake diamonds using few detecting metals. To test this, 5 boxes were set up, 1 containing diamonds and the other 4 does not. As such, the probability of obtaining a box with diamonds is 1/5. He is to determine the box that contains the diamond. He will be allowed 19 attempts, thus the number of trials n equals to 19. To receive an award, Xavier is to make 15 or more correct identification. Noted also that he had claimed the probability he will make the correct identification is 0.7. The first part of this question requires us to identify several probabilities. First, following Xavier's claim, determine the probability that he will make 7 or fewer correct identification. Mathematical notation of this will thus be P x less than equals to 7. Calculating using binom CDF in your GC, we obtain the probability of 0.00282. Secondly, we are to determine that Xavier make exactly 7 correct identification. Mathematical notation of this would be Px equals to 7. Calculating using binom PDF, we obtain the probability of 0.00282. 221. And finally, we are to determine that Xavier received the award. Mathematical notation of this would thus be px more equals to 15. Calculating will be 1 minus px less equals to 14 as we're using binom CDF. We obtain the probability of 0.282. Last part of the question assumes that Xavier will simply guess where the box with diamonds are placed. Henceforth, the probability to succeed is 1 over 5, which is 0.2. To determine that Xavier receives the award, the mathematical notation of this will be similar as before, which is px bigger equals to 15, calculated by 1 minus px less equals to 14. However, the values of p has changed to 0.2, so the value that we obtain here is the 1 minus binom CDF of n19, p 1 over 5, and x 14, and we got the answer as 5.54 times 10 to the power of 8, which is approximately 0. Question 4. Note the information given. Firstly, we note that the distribution is normally distributed, shown here, with a mean of 120 and a standard deviation of 12. Part A requires us to clearly mark on the horizontal axis of this distribution corresponding to the distribution of the earnings taken over the first 2-hour period of sales. Remember the empirical rule discussed in the earlier topics of Chapter 7? We mark the horizontal axis by plus minus 3 of the standard deviation from the mean, as follows. So here is the mean at 120. First standard deviation, second standard deviation, third standard deviation. The first standard deviation will be 132. Next we have 144 and 156. Going to the left, 120 minus 20 minus 12, we have 108. Minus 12 again, we have 96. And minus 12 again, we get 84. Part B requires us to construct a 95% confidence interval for the mean earnings. Using GC, we obtain the 95% confidence interval of mean earning that lies between 96.5 to 143.5. The interpretation of this answer would thus be that we are 95% confident that the mean earnings obtained per store lies between 96.50 RM to 143.50 RM. Part C requires us to find the probability that a randomly selected store has earnings of at least RM 160 over the first 2-hour period of sales, and they would want us to leave our answer to the nearest 3 decimal places. Mathematical notation of this will be px bigger than 160. Calculating using your NCDF with a mean and standard deviation of 120 and 12 respectively, we obtain the probability of 4.29 times 10 to the power of negative 4. As the probability calculated above is close to 0, this signifies that it is very unlikely a store would earn more than RM 160 over the first 2-hour periods of sales. So we're going to write it this way, as px is bigger than 160 is approximately 0, unlikely that we will get a value of 160 or more. Part D requires us to determine the smallest number of stalls n that should be planned to achieve a margin of error at plus minus RM4 with a 95% confidence level. Using the formula to determine the sample size, n in bracket 2 times 1.96 sigma over w square. Substituting our sigma and the respective width, we have 2 times 1.96, sigma is 12, divided by width, plus or minus 4, that means width we need to multiply by 2 to give you 8, square that, give you the answer of 35. Last part, part E. After conducting several annual charity drives where improvements were made to the store layout plan as well as the variety of products sold, it was noted that the sample mean amount of earnings for 30 randomly selected stores is 141.20 with a sample standard deviation of 14.80. Using this set of data, the organizing committee issued the following statement. The committee is 95% confident that the mean amount of earnings is between the two values. Show the necessary calculation on the mean mu that leads to this statement. This statement is obtained using the confidence interval formula at 95% confidence level, thus substituting the values of sample mean x bar, sample size n, and the standard deviation of RM 1480 into the formula proves the statement issued. The steps are x bar minus 1.96 sigma over square root of n to mu x bar plus 1.96 sigma over square root of n. Substitution, you have your answer, which is 135.9 to 146.5.